this is a direct back entry to the fuse board, then the fuse board is somewhere around up there. The car charger could be here. So I'm going to do a number of measurements I need to do just to make sure we are right here. And I've got a few reference points. Either the window, the edge of the house. I need to understand the cavity, the thickness, everything, just to extract that measurements and be here. Or I can just go ahead and drill straight through. What am I going to do today? Honestly, I don't know. We've got Hypervolt Home Pro, I think it's Home Pro 2 that we are going to install. And challenges, am I going to drill through a supply cable? Let me show you what we've got here. This charger, that's where the fuse board is, right behind this conduit. Supply cable is coming from here, but how? We don't know. It's going somewhere in a cavity. I have to drill through the cavity wall into the fuse board. And am I going to drill through our cables today? Am I going to have to uncover the wall, go into the cavity and fix what I'm about to damage? Well, hopefully not. As a Part B in England, you can run the cables vertically and horizontally from any outlet. So I could expect cables, well, I can see obviously trunking. I know this is going to the actual loft. This one is just the data, maybe one supplied to the other rooms. That is directly from the actual fuse board. But there could be cables anywhere here. Well, we can clearly see some patching up. And we need to run a 6mm to the outside. Let me open this up. Let's do like a visual inspection. And hopefully we can get this sorted, drill through the wall and not creating a big shock. Let's do it. Definition of a full fuse board, here it is. We've got one CT clamp. We need to find a room for another one. I think this is for a smart meter. Client doesn't have the solars yet. So there might be a fighting challenge for the actual space. That's another problem we'll have to solve. So as you can see, this board is pretty full on with everything. And we need to find a room to fit another cable. We are absolutely seeing nothing because it's all being sealed up with the fire intermittent silicone. Honestly, this will be an interesting one to actually do it, and I hope we can pull this off. Cable, supply cable, they are coming through this hole. They're not super long. Maybe we'll be able to reposition the CT clamps to go on the back of that cable. We'll hope so, because there won't be any room for two of them, or otherwise we'll need to run one externally to the incoming box just outside. The question, is there any cable going right through here? The honest answer is I don't know. What? But I think to limit the risks, I'm actually going to drill just lower down where the actual EV is going to be. Drill straight outside, because that will give me the best possible option to minimize the area that I have to drill. And if I do end up drilling for a cable, then I will know exactly what it is. Usually I would aim to drill at the steep angle straight to the back of the board, but well, not in this occasion. It's too many circuits, it's a higher risk of running through a cable. It is less likely that there might be a cable coming down because the actual staircase is in the way. So this is proving to be a bit more difficult to run the cables. The original installation is still in situ, so there might be a cable coming down. But I'm kind of like set on entering the fuse board from the left-hand side, because there's actually a room for me to do this, to put a trunking, hide my cable, and just make off everything I need to do, and then drill from the outside in. And if anything blows, you will be the first one to know. Cool. Here we go, the wall brackets. Nice color. That model is tethered with 5 meters of the cable. We've got the actual bracket, and hopefully that's where we have our CT clamp and the rest of the CT clamp, the connection for the back, and the actual hook for the cable. Screws to mount this to the bracket. The CT clamp. Oh, I'm glad it's not one of those big massive ones. Let's hope that this will fit in nicely. This is super important. On the CT clamp, you've got L, load, K, that's the supply. So the energy has to flow from outside grid to your home, and that's how you have to put it around the cable, not the other way around, because it won't work. And you can burn down your main fuse. If this is a direct back entry to the fuse board, then the fuse board is somewhere around up there. The car charger could be here. So I'm going to do a number of measurements I need to do just to make sure we are right here. And I've got a few reference points. Either the window, the edge of the house. I need to understand the cavity, the thickness, everything, just to extract that measurements and be here. Or I can just go ahead and drill straight through. What I'm going to do today? Honestly, I don't know. I do want to be on that left-hand side. I know I'm showing right, but on that left-hand side of the fuse board. So kind of drilling inside out, maybe a bit more precise, but just the height needs to be good. So the bottom lower of the window, that's where the charger would be. It's kind of higher to what you might normally install. But anyway, if you're thinking about bringing your car in, customer will be driving an SUV. Usually the curvature of the door, hold on, it's nice and straight. The curvature on the SUV, I think, is just slightly a different way. So you see that the top portion actually protrudes further than the bottom. On the SUV is the other way round. I think mounting it higher up, it is actually a better option. I still need to account for, well, maybe there's no plasterboard, but yeah, if we take the edge of the window to the left side edge of my fuse board, so the further end, it's 104 and about 98. I've got that ideal window of where I want to be with my cable. Remember, that distance of that window when I measure from the outside could be slightly different. Just against some quick visual references, I can see that the top of the window is not exactly, let me show you. The top of the window is there. So that's still a good indication for me where is the actual bottom of this fuse board on the outside. Just get a better understanding of what this looks like on the other side. Let's do this. So this is the edge of the window, and we're gonna go 101. So 101 is here. I'm gonna make my mark. So this is where I'm aiming for my actual cable entry, right there. So that's where the actual thing will sit in a moment, or maybe slightly lower, but no, I think this will be it. It lines up with the window seal. The height of the window on the inside, it's about there. So maybe that will be the bottom of the fuse board. If you're asking me where the fuse board is, right where you've got the line of vertical bricks, that's where the fuse board sits.
Nice.
The cables are going left, about there, that height. So pretty much what I need to drill through them. That's where the cables are, that line. And I'm drilling here. And I will take the small angle, as we don't want to drill through a cable. This is how you might want to do it. This is a size 8, the actual end of it, so it's quite snug. Let's introduce a bit more light, that's 100%. Okay, we've got the insulation, just trying to get to the outer bottom. No, I can't see anything. Let's do this one. Okay, I did move, create like a little round thing. I cannot see anything, any cable or anything as such. Cool, I would say it's safe to drill.
A few moments later.
Well, we are exactly what I thought we will be, just below the handrail. Where are we in relation to the actual fuse board? So that's the side of the board. The measurements is further to the left, so the actual opening on the outside is wider than the inside. So my 101 centimeters were further to the left, but I'm still good. I'm still what I need to be, so I'm quite happy. We still got 5 more drill sizes to go. That's 16 to 18. 18 to 20. 6 mil will go nicely through that 20, but I need 6 mil and 2 data cable. So I am doing 25. Okay, that should allow us to go through. Lovely jubbly. Let's go on the inside. Oh, we can kind of see inside, can you?
Yes, we can.
We're going to use a silicone, put this to the back entry into the actual unit, cap this off, we extend, put some sealant inside, all the way in. First things first, this fella, you just hook the bottom, just like so. The top lines up with this screw. This is just to grab the unit. We are not doing the final connections just yet, because we need to take it off, drill the back of it. Okay, this just comes off. Remember, when you open this for maintenance, this lead is attached for that LED to tell you what current status the actual charger is, so take that tip. This is where we are connecting. I see more and more EV chargers now with the actual Wago connections, so we are coming out anywhere there, but I want to be quite precise because I've got conduits, so I don't have a room for messing this about. On the back of it, I should have the actual exact point where I'm going to, or what I should be drilling. That's what I'm on about. Max 25 mil. We don't need 25 mil. Oh, that actually worked. Charm. Oh, happy days.
One eternity later.
If you don't want to blow up this main fuse, listen to what I'm going to tell you. Right there, this is a connection to a CT clamp, and that goes inside the house and is clamped onto this brown cable. And that brown cable, it's running all the power to the house. But what we want to do is, this is the ALM switch dial, and it has a different settings. This one, we actually going to set up to 60 amp. Hypervolt, oh, this is the Home Pro 3, but anyway, in your installation guide you will find ALM, automatic load management, from 0 to 9. It tells you what are the different settings for your load management. We went for 6, that's 60 amp, and this is pointing like slightly down and left. You can see that clearly here. I'm happy with the 60. That would work. If you do that, that will keep your house safe, and it will keep your service fuse safe as well, and that's what you want to do. Once you secure the first cover, you've got this fella that goes right on top. So these contact points, they all joined up together. Hey, it's blue already. It talks nice blue to me. Now, let's decide where we are going with the cable, and there's also one final test. And the final test is for the actual end socket and cable, to make sure that it's all going absolutely right and nice through the EV charger. Well, the Hypervolt is already charged. We tested it, but it's raining, so I really need to move my stuff in the car. But yeah, hello. Great stuff.